What's up, everybody? Today we'll be doing USACO's US Open problem number 3, 2021, Acowdemia. And so in this problem, if you're familiar with Google Scholar's H index, you'll understand some of it. So in this case, Bessie, which is always in every problem, is a doctor, and so she has a couple of these papers. So she has N papers, as like an array style, and each paper has C citations. Okay, and she also has an H index, and so H index is defined by at least H papers with at least H citations. So what does that mean? Well, if I have an array 4, 3, 2, 1, I have an H index of 2. Remember, this is sorted greatest to least, so that's pretty important. Because I have at least 2 items with at least items that are greater than or equal to 2. Now, I don't have an H index of 3 because I don't have 3 items that are greater than or equal to 3, because 2 is actually less than or equal to 3. So my H index is 2. Now, if I change this, I'm going to erase all these extra stuff too, to a 3, now I have an H index of 3 because I have 3 items that are greater than or equal to 3. Okay, so that's the basic idea. Yeah, cool. So in order to increase her H index, she has these things called survey articles, which can help increase citations. But she can't add any new articles. That'll be important later on. And so with survey articles, they work like this. Let me show the 2 examples. So I'll just delete everything. Okay. I'll show the 2 examples. So if I zoom out, this will be example 1. That was weird. And example number 2. This is in the problem, so if you want to follow along, go on the website. I'm pretty sure it's 441, and this is 414. This will be N. Let me put this up here. This will be N, this will be K, this will be L. And so how it works is she's given the same exact array, actually. And this is sorted greatest to least. That'll be important. And so what she can do is, imagine you have like 4 different like circles, right? And these represent 4 of her possible survey papers or survey articles, case survey articles. And L represents how many articles he can add citations to with each survey article. So actually, it would be actually really nice to put these circles right above the actual array, and you'll see why. I'll do that here. But in this case, you only have 1 circle, but can add citations to 4 different articles. And so you'll see the difference. But so there's 4 right here in example 1. There are 4 different survey articles, and they can only add to 1 article. Now here, I can just put this here. I can put that here. Or actually, put that there, and then put that there, put that there. And I would end up with this. And then my H index, my greatest maximum index with these survey articles is 3, because I have 3 elements that are greater than or equal to 3. Now with this, I can add 4 different articles. Now I can't just add 4 to this, because you can't cite the same article more than once. What it does is I can choose 4 different articles and add citations to them, add 1 citation to them. So in the end, the only way to do it to increase is with this. And this only has an H index of 2. That's the explanation for these 2 guys. That's why this is 3, example 1, and this is 2. So your goal by adding these citations, how are you supposed to, or what is the highest H index possible given K and L? So, I'll give you some time to think about it while I erase, but the answer is a lot easier than it seems, or it always is a lot easier than it seems. I always overthink everything. So, how do you do it? You'll notice that when you have an H index of something, let's say this has an H index of 4 because I have 4 elements greater than or equal to 4. I also have an H index of 3. I have 3 elements greater than or equal to 3. I also have an H index of 2. I also have H index of 1 and 0. Okay. This also means another thing. So that means I found a lower bound. So the lowest it possibly can be is 0. And we know that the H index 4 is also true. You may see where I'm going with this, like this. You also notice that there's also an upper bound. An upper bound meaning that since you can't add any publications or articles, the highest H index the array can possibly have is n. So your answer is between 0 and n. And since you know one side's going to be true and one side's going to be false, or no false at all, or no true at all, this has the conditions for binary search. And if you don't know what binary search is, well, learn binary search. I'm not going to teach you necessarily, but with binary search, you also, in this case, you want to find the last true, meaning the highest H index you can possibly have, the last true, if you're trying to implement it. I should probably erase all this too. With binary search, you want to have failure cases to tell whether it is true or false. So I'm not trying to explain all of binary search, but usually in binary search you have like a function or something to determine whether the possibility works or not. And you want to binary search how many if the H index is possible or not. So is H possible? Well, you can determine that by 2 ways, or with 2 simple true or false statements. 1, you'll notice that the array in total, the sum, can be only added by k times L, right? So when I add 4 different k's, right, the whole thing is increased by 4. So this total is 103. At the end of the array, by adding it, is 107. Same deal here, except you only can add 1 to each one. But the whole array is increased by k times L. Or array is increased by k times L. Okay. So if the difference between like the required number for the possible H index is greater than k times L, it's not possible. So also one thing you want to know, like I said earlier, you want to sort your array greatest than least, because it's more optimal to want to check the first mid, which is first H, if you're trying to check if H is possible. First H numbers, because it requires less cost to make sure. So let's say H is 4, right? You want to see if H index 4 is possible. You only want to check the first 4 elements. See, yeah, and you'll see that the cost is only 1 because you only need 1 from 3 to make it 4. Same deal here. If you check only like the last 4 elements, you'll notice the cost is like 2, 3, total 6. Okay, so you want to check the first 4 and sort greatest to least, or you can just. And so if you add up all the costs, that's if k times L is greater than the cost, it's impossible. Another note is a certain index or a certain like element can only be increased by k. One element can be increased up to k. And it's super messy, but hopefully y'all can deal with it. It can only be increased up to k. So remember this, right? Each element is only increased by 1, and you can't say the same thing twice. And you'll notice this observation after a couple of, I guess, practices or like test cases. So with this, you have your 2 failure cases, and you just binary search it. Let's just look through the code, right? Don't worry about all this gibberish. I'll pull down the binary search code I copied from Benji. But yeah, this is last true. Like I said, the true or false. You want the last true. K times L, I read K times L. Some people use CN. Java uses scanner, or I think like buffered scanner or something like that. I don't really get to do Java, but and then here I have my function, and so it just basically does binary search. And f is my function and tells me whether it's true or not, and K times L right here. And then this is just whether if it's greater than k, or let me just zoom out. Increase up to k. So if an element requires like if h minus the element is greater than k, it's impossible. And so yeah. Yeah, that's how it works. And this is just binary search. It's not too bad actually. I think the hardest part of the problem was probably finding that this car can only be increased by k, but that's it. I mean, after you notice that, it's pretty easy. It's just binary search, and yeah, I guess maybe noticing binary search is also pretty hard too. But overall, this wasn't such a bad problem, and usually people get scared because it's like US Open. It's usually the hardest one of the year, but it actually really isn't that bad. And yeah, actually the maze problem was pretty hard. I didn't solve it, but the solution was pretty cool. This also has a ridiculous amount of test cases, 20. But yeah, that's Acowdemia. See you next time. Post in the comments if you have questions, and see ya.